As discussed yesterday, about the agenda of the course, today we'll be talking about the version control system, right? Like in the CI/CD pipeline, this is the first tool we'll be coming across. Like whenever developers push the code, we pull from here and we execute the pipeline. So anyway, we are going to talk about that now in detail. So the first tool in our course is a version control system. So some of you might have used some version control system, some of you might be new. So let me take over from the beginning. So what is a version control system? What does it do? Anyone who have any idea can feel free to share your inputs. What is a version control system? And why do we need this? Okay, to understand this, let's take up a simple scenario. Let's say there is some project, okay, some project and all the remote work, or else let's say all the project files are kept in some remote location, right? A place, a shared folder across the team, right? Let's suppose there were different people working on it and there could be multiple files, isn't it? Just give me 1 second. You are seeing the blank page, right?
Yeah.
Yes.
Right. So let's say there is some project where we have a multiple files here, right? And multiple people were working. Let's say this is some shared folder across the team. There were two people, two DevOps persons, or let's say two developers, whatever, whoever they are. Let's say there is developer A or else a person A, person B. Both have to work on some file, file one. So this person A got this file to his local computer to make the changes. At the same time, person B also downloaded this file to his local computer. They were both working on it. They both made the changes. And let's say on day one, this person A kept the file back, right? On day two, this person B kept the file back, right? Both of them kept the file back, but person A on day one and person two on day two, person B on day two. Now this file one, after both of them placing their changes, will have which person changes?
Person B.
Person B, right? Obviously, simple logic. What's happening here? Person A changes are being overwritten by person B changes. Correct? Person B, because he is the one he kept the file last. So his changes are overwriting person A changes. A doesn't know this, even B doesn't know this. This is happening without the knowledge of others, right? This is happening for everyone. Maybe there is a chance that this may happen for everyone else. There might be so many people working in the project, isn't it? If this is the case and this keep on continuing, the project gets corrupted or messed up in some time, right? This would be the result. But how to handle the scenario? Because always there'll be multiple people working on the projects, isn't it? It's not that just a single person works on it, it's a teamwork. So definitely more number of people will be working here, right? So how to handle this scenario, or else how to handle this scenario so that one person changes will not work on, will not overwrite other changes. Yeah, because people have to work parallelly, simultaneously. So there comes version control system, which allows teams to work parallelly, simultaneously. That's what version control system does, right? People can work parallelly, simultaneously on the same file. But version control system, if you are using, it will not allow overwriting. It will not allow ignoring some changes. That's what version control system does. One of the things what version control system does, because this is very practical, isn't it? It's very important. It's not that when multiple people are working, it overrides the changes, or else we cannot see. People will be concentrating on working on their files, right? They might be developer or DevOps team, whoever. They'll be working on their files. It's not that they take care of whether the changes are saved properly or not. That's the first thing. Second thing is, let's say something went wrong. Okay, application is working fine till 7 o'clock. 7:30 application failed. Business will go down. Immediately you want to put back. So if you want to bring the system back, you need to know what happened, a detailed log, like which person made, let's say person A made changes to file 1 on line number 6 at 7:10 a.m. This kind of detailed logging is very important, right? So that, okay, we know some changes were done by person A, okay, we'll remove or we'll revert those changes. So we need a system which can provide this detailed logging. Can we do that manually? Practically, is that possible without any version control system? Yeah. We'll be concentrating on the requirements, we'll be concentrating on the scripts, developers will be concentrating on writing their code to achieve the functionality, right? You can't just make this or prepare this log manually. You can't do that. So that's where again version control systems comes in. Not only that, let's suppose you are working on version 1, okay, of a file. Client came with the new modifications and they want to make a version 2 of the same file. So let's say you have edited the same file and made version 2, or else you have deleted it, made a new one. Okay, fine. You have got version 2. After 6 months, client may want the same version back, right? Is that possible? So you need to again do rework, right? Because you have deleted it or else edited the same one. Don't ever do that. What you have to do? Yeah. Instead, you have to take backup of the file or maintain versions, which is again possible through version control systems. These are some of the features of any version control system which can help you manage your files. Now, okay, developers, yes, they have program files, they have lot of code, definitely they need this. Then why do a DevOps person need this? See, everyone need this. DevOps person also have configuration files, script files, right? They have to manage them. So definitely they need a version control system, right? And also even testers, QA team, they do write test case, automation test cases. They do have scripts and the files. They have to version control them. So not only developer, DevOps teams, QA, everyone in IT should know this version control system. Even to manage your files, personally, you may have some files in your system, right? If you want to manage them again, you can use this version control system, right? So that's what version control system does. So everyone should know this. And also this version control system can manage any static files. It could be a Java program file or a Python file, C#, Groovy scripts, CI/CD pipeline scripts, Ansible playbooks, Kubernetes manifest files, Terraform config files. All of these will be version controlled, right? So we will be using this Git throughout the course to manage our files. We will be pushing, pulling, we'll be using throughout. You'll be getting complete hands-on on this tool in our course, right? So we will be learning version control system first from the perspective of managing your files. Then once that is done, then we'll learn it how to integrate in the pipeline and use it for the continuous integration, continuous delivery purpose. Right? We'll be learning it from two perspectives. First, let's learn it from the perspective of managing the files. Am I making sense? Understood, everyone? Clear?
Yes, ma'am.
Right?
Yes.
Okay. So that is what version control system does. And version control systems have got different architecture, or else based on the architecture, they were categorized as centralized version control system and distributed version control system. So let's see what is each of them. First, let's go through centralized version control system. Centralized version control system, if you see, it has got two repositories, a central repository or a remote repository and a working directory. What is this? This is nothing but the workstation of individual user, developer or DevOps person or call, whatever, whoever you call. This is the, let's say, the local computer of every individual person. And this remote repository or the central repository is where all the project, all the code base is kept. Right? So this is the repository. Now everyone will connect to this remote, get the files, get the changes, make their changes locally and push to remote. That's how the central version control system works, right? So it is very simple architecture. There were few challenges. Like always network connection should be there to the remote. Then only they can connect, get the changes, make the changes and put it back. Let's say there is network disconnected. Entire work will be halted, right? That is one drawback of this version control system of this type of architecture. Second thing is your code is kept on the central server, right? Your project files are kept here. If for some reasons, if the central server is crashed or gone, entire code or entire project is lost, entire code is gone, right? It's like a single source of truth. Chances of recovery are very less. These are the two challenges you have with the centralized version control system. To overcome this, you have the next type of version control systems, which is the distributed version control system, right? Distributed architecture. Let's go through that. Yeah. Here, if you see, this is the centralized architecture where you have a central repository or remote repository like earlier. But now every collaborator, every user will have his own repository, this one, which is called local repository. Called local repository, right? And this is called central repository, right? Or remote repository, whatever you call this. Central repository or remote repository. This is the local repository. Every user will have this local repository. This is the workstation of an individual user. And now every user will have a copy of this remote repository, which is called, actually this is called local repository. This is the workstation. The box I draw here is the workstation of individual user. This is the workstation of individual user. And every user will have a copy of the central repository, which is called local repository. Right? Everyone will have a copy. And they will not work directly on this local repository. Rather, they'll work on another directory or another folder called working directory. Right? So they will work on this working copy or working means like, let's say another folder. They'll work here. They'll make the changes here. Once their changes are done here, they will push them to local. And from local, they'll push them to remote. Right? See here, from working directly, they'll push the changes here from here to here. And until they push the changes to remote, if their changes are only in local, they're confined only for themselves. If they want to share it with others, they'll push to remote. Right? This is the distributed version control system architecture. And this overcomes all the drawbacks of the earlier architecture. Meaning, in the centralized architecture, if you see, if network connection is disconnected, entire work is altered, right? But that's not the case here. If the connectivity, if network connection is disconnected, network is disconnected, they can still continue work on local, right? Once their changes are done, then they push to remote, right? And means still they can continue working on local, right? That's one thing. That's how it overcomes the network connectivity issue. Second thing is, even though the central server or remote server is crashed or lost, because everyone is having a copy of local, chances of recovery are more. That's how it overcomes the challenges of centralized version control systems. Clear with the architecture, everyone?
Yes, madam.
Yeah.
Yes.
And our Git falls under this distributed architecture. Git is a distributed version control system, right? And all the modern DevOps projects are using Git very widely. So if you master Git, you can work on any other version control system. But again, Git is very widely used nowadays. So Git Mercurial falls under this kind of distributed architecture, and centralized version control systems are SVN, TFS, Perforce, all this comes under centralized architecture. Git, Mercurial, Fossils falls under this distributed architecture, right? I'm repeating one more time. See, every user will have their own copy of remote repository. Okay, again, directly they'll not work on that local copy. Rather, they'll work on a working directory, means another folder. From once the changes are done, they'll push to local. From local, they'll push to remote. That's how the changes move from working directory to local and from local to remote. And now that we learned the architecture of a version control system in general, we will talk about architecture of Git in particular. Before that, see here, this is the Google Trends from 2020. You can also check out the latest graph, right? When Git, when compared with other tools like SVN, TFS, Fossils, the blue graph is for Git. Git is very widely used and is a leader in the category. Do you see that? Yeah. So and then comes the architecture of Git. We have learned the architecture of distributed version control systems in general. Now the architecture of Git. So here if you see, like as we discussed, this is the workstation of any individual user, right? And this is a remote repository. So you will copy from this remote and create a local repository. Again, you don't make changes here directly. See, you will make in a working directory, make the changes here. Again, from working directory, you can't push this way. It's not that from working directory you push to your local. No, this is not possible. From working directory, you have to push your changes to staging area. What is the staging area? Staging area is nothing but a virtual layer. It is also called as index area. It's a virtual layer. It's not a physical thing. It's a virtual layer. From your working directory, first you have to move your changes to staging area. From staging area only, you have to move to local. That's how you move. You can't just move from here to here. No, that's not possible, like we discussed. So you will have a directory. From there, you will move to staging. And how you will move to staging area, we will learn that. Okay, you will move to staging area. From staging area, your changes will be moved to local. From local, yes, you can push to remote. You push to remote means others can also see your changes, right? This is called Git tree or Git architecture. You might be having a question. Why should you push to staging area? What is its important? Like I said, it's also called index area. It's like for preview or else pre-check before your changes move to local repository. Or else let me put you this way. This will help you have better control on which changes you are pushing to local repository. Let's suppose you have 10 files in your working directory. You want only 5 files should go here, not all of them. So you will put only those files to staging area. And when you commit, only those files will go to local. Anyway, we will see all of this. What is this working directory? What is this local? We will see everything practically. Okay, first I'm explaining theoretically. We are going to see this practically in few minutes. So it will help you have a better control on what changes going to your local. Okay, so this is called Git tree or Git architecture, and this is how the changes moves, right? Here, let me tell you few interesting things. Till now we were talking about, okay, this is one folder, this is like virtual thing, and this is another folder, right? Strictly speaking, this working directory, okay, and so this working directory and this local repository is physically one and the same folder. It is the same folder. Yes, if you are a Windows person, yeah, it's the same folder. If you are a Linux, it's the same directory or folder you call it, right? So it's the same folder. Then how come you say local repository and working directory if it's the same folder? Isn't it? It is the same folder physically, but logically they are different. How logically they are different? Let me tell you. See, this is your folder. Let's say this is your local repository. Like I am saying, the same is the working directory. How is that possible? This is possible because let's suppose you create a file here. You create a file means it's said to be in the working directory. Okay, then you add the file. You add the file, you run the command git add. You run the command git add means it is said to be in the staging area. Okay, and then let's suppose you have committed the changes. Then you say that's in the local repository. But the file is in the same folder. Understood the point? You just created a file or copied a file from somewhere and placed here means it's said to be in the working directory. Right? If you add the file means it's said to be in the staging area. If you commit the file, that's said to be in the local repository. Got the point, everyone? Understood?
Yes.
It's the same thing. You will call sometimes working directory, you will call the same as local repository depending on how your file is. Right? This is one interesting thing. We are going to see this. And the second thing is, how do you create a local repository? How do you create local repository? Local repository can be this one, yellow box. How do you create a local repository? Local repository can be created in two ways. One thing is you will copy from remote, right? And create a local repository. That's one method. Means, see, let's take a use case. Let's say you have joined a project. It's a 6-year-old project. Already the project is on remote. Okay. Already there were so many Terraform config files. You joined the project today. So there is something on remote already. You copy from remote and create this local repository. That's one way, one use case. Second use case is, let's assume this is a new project. Okay. Team is formed today. It's a completely new project. Okay. And now you create a local repository manually. Create a local repository manually, an empty one. Okay, then you develop the config files here, make the changes here, then you push to remote. Right? Those are the two use cases. We will be taking up both of them practically. First, we'll start with the second use case. So this is how it works. Now we will talk about the second scenario first. Understood both the use cases, everyone?
Yeah, hi Preethi. I have a question here.
Hmm.
So, this is something, this version control is only applicable to this DevOps persons, or this is in a generalized thing? Because, for example, let me give you an example. So, suppose we are using Microsoft Teams application. So, the same scenario, right? If we would like to upload some files, so in central location, so we'll be able to upload, and then will be able to download, right? So, version control is specifically to Git, or it's for all kind of cloud-based application scenarios?
Version control system is to manage your files. Have you worked, may I know your role?
Yeah, admin only.
Okay, so you'll have some scripts, right? Scripts, config files, and so on. How do you manage them?
Manage them is same like you are telling, some local repository and working directory and all. So the same thing again. Suppose in Windows machine, folders will be there, and in folders again some subfolders will be there. So that can be something. Local repository is something kind of folder, and working directory something kind of subfolder.
Yes, local repository working directory is nothing but a folder. But here you are working in a team, right? In a team, there will be so many people. You have to share the same work with other team members, right? Within your team. So how do you do that? And also, how do you maintain versions of your files? Let's say you have version 1. Tomorrow you have to make some changes. Still, you need the backup, right, of the old file. How do you do all of that? That's where these version control systems comes in. This should be used. Nowadays, everyone is using it. Testers are using, developers, DevOps teams, everyone is using it. Everyone have to use it because everyone have the files, right? Config files, scripts and all.
So renaming the file, suppose I have multiple files. So
Hmm.
suppose version 1, version 2, version 3, something this we can maintain, right? This is how.
You can maintain. You will see practically, you will get the clarity on it. Yes, you can manage the multiple versions of the same file.
Okay, okay. Yeah.
This is a version control system which can manage any sort of files. Any static files can be version controlled. So everyone should should use this version control system to manage their files better. For the reasons I stated in the beginning, might be you might have joined a bit late. In the beginning, I was talking about the scenarios where version control system comes in. So have a look at it again. Briefly, I can say this is to manage your files, share the files across your team, collaborate with your team better so that one person changes will not be overwritten by others and so on. So these are the two use cases, how you can create a local repository. We will do both the use cases. Today we'll get started with the second one. Second one means assume it's a new project. Okay, there's nothing on remote. Let's say it's a new project and we have to create a new local repository, develop it, then push to remote. Okay, so we will see how to handle this. And this architectural diagram is very important. You have to remember this throughout. This is already available in the Google Drive. So now that we understood Git and the architecture, let us install Git. Okay, by the way, Git works on any operating system. It will work on Windows, Linux, Mac, and so on. So whatever laptop you have, okay, you can install Git there. How to install Git? Already the documentation, everything is available in the drive. Okay, also I will show you now. In the Google Drive, you have all the documentation available. So this is the presentation which I am going through, and here are the installation things. Now let's go to Google and type in Git installation. Okay, go to the official documentation, gitscm.com. Here you can see, do you want to download it for Mac, Windows or Linux? Okay, I have downloaded this for Mac. I have clicked this. If yours is Windows, go here and download the executable. Okay, and then once you download the executable, you have to run the executable. You know that part, right? You might have done that many times for any other installations. Same is the case. Run that executable. You will be taken through the installation wizard where it asks for confirmation. See here, all the screenshots of installation on Windows is available here. Okay, download it and start the exe file. See, click on this Windows. This is the executable downloaded. Double click to run this. And you keep hitting next, yes, and so on. Give confirmation throughout all the steps. And yes, Git will be installed. Once it is installed from the start menu, you will see Git bash. You have to launch that where you will run all the Git commands. That is how you install in Windows. In Mac, you can also download it almost the same way. Like you can go here, you can install it through brew install Git or port install Git will do in Mac. In Linux, just the package manager again. Minstall or apt-get install will do. Right? Again, we'll do it on Linux also. Okay, for now, let's do it on your Windows machine directly. You can install it, right? And as I have got Git installed, you have to open Git bash if it is Windows. Okay. You have to open the terminal if it is Mac. That's all. And check the version, Git version. You can see, yes, Git is installed. Okay, fine, Git is installed on my system. Like you can create a folder or a project which will be managed by version control system. Okay, here I am going to create a folder called Git demo. By the way, I am doing everything from the CLI. You can also do it from the UI. Meaning just go to your desktop, right click, create a new folder. This is the way you can also do it, right? Am I making sense? You can do from the UI if you have Windows user, or else Windows user also can go to Git Bash and do it from the CLI. These CLI commands are Linux commands. I will teach you these commands separately. So if you are completely new to Linux and not comfortable with CLI, you can use the GUI. Like you do in your daily life, you go there, right click and create the folder. Or else use mkdir, small CLI command. Okay, small Linux command. Mkdir means create a directory. It will create a directory called Git demo, where it will create on the desktop. Okay, now create the directory. See here, ls will list all the folders, all the directories or folders, whatever you call it. So here is the folder, go there. Now my idea is I want to place all the files here. Just a second. Okay, so there is nothing here, right? Let's say I want to put all my project files in this folder called Git demo. So meaning I want to tell Git to track any files in this particular folder. How do you tell Git about this to track the files in this folder? What you can do here is do git init. Git init means initialize Git. Start Git in this particular folder. Okay, when you do git init means this becomes a local repository. Means Git init is the way to create a local repository. I'll show you here diagrammatically as well. Give me a second. So this is the folder I have created. Okay, I just created a folder on my desktop, named it as Git demo. Now I want to put so many files here and I want Git to version control all those project files. So I want to make this a local repository, or else I want to tell Git to version control everything here. So what do? Run git init. Git init means initializing it, starting it. So whatever files present here will be version controlled by Git. Right? So that's what I'm doing. Now this particular folder, Git demo, is nothing but local repository. Sometime back we are talking about, right? You can create a local repository manually. That's what we were doing. Now, yes, this Git demo is nothing but your local repository. See, when you run this, it says initialize empty Git repository. Do you see that? Also, if you see the hidden files, ls-a will show the hidden files. .git, right? If your folder is having .git means it is nothing but your local repository. It's nothing but your working directory because both are same physically. Am I making sense? Understood? Yeah, this is the one created. And if you are not comfortable with CLI, you can also do this way. And if you want to see the hidden files, do we have option to see the hidden files here? View. In Windows, there will be an option where you can see the hidden files. I'm not sure about this, but you can see the hidden files. View options. Show icon, show relative dates, tag size. Maybe I'll stick for this option later, but yeah, you can see the hidden files here once you enable that option. Okay, or else from the CLI, you can see this way. Right? You are seeing .git. Means local repository is created. Right? Okay, fine. Local repository is created, but I don't have any files. Shall we create some file? Yeah. How can you create a file? Yeah. Just go to this folder. Okay. Create a file here. New file. Or else we can create from the CLI using touch. Let's say I want to create file 1.txt, a text file, right? ls text file is created. Okay, just some dummy files I'm creating. If you want, you can also create any files with HTML files or C# files or whatever you want, you can create. Here, our intention is not to learn those scripting or all. We are concentrating on managing those files. So you can create the file, any file of your choice. I have created this file. I just created the file. Means, can you tell me where is this file? Git demo is nothing but working directory. The same one is called local repository. I just created the file means, where is this file? Yes?
Working directory.
Working directory, right? If you want to know, let's say I'm new to Git, run git status command. It will tell you where is the file. See here, it tells you untracked file, file 1. And it is saying nothing to but untracked files present. Means Git is saying untracked. Means Git is not tracking the file. Git knows there is a file, but it is not tracking. It will ask us to add. See, it's giving a clue, git add. Git add means where will this file go if you do git add? Do you remember the architecture?
Staging
Always
area.
remember this architecture. So it's in the working directory. And if we add it, where does this file go? Yeah. How to do that? Git add file name. Now if you run git status, do you see that? Changes to be committed. It's not saying untracked now. It's saying changes to be committed. Now can you tell me where is the file?
Staging area.
It is in the staging area. Yes. Now, if you want to commit git commit -m, let's say see -m means message. Message is mandatory whenever you are running commit. Let's say first file, some comment so that you can understand what this commit is about. So it says that it has inserted. Okay. And then if you do git status now, it says working tree is clean, right? Working tree is clean means all the changes were there. Now, where is the file? Can you tell me? Where is this file now?
Local repository.
Local repository.
It is in the local repository, right? So that's how it works. Always you have to keep this architectural diagram in your mind. Always this architectural diagram in your mind, right? This is how your changes moves from working directory to staging area, from staging area to local repos. But physically, it's the same folder. It's the same Git demo folder. Logically, that's how it is different.
Preethi, Atul here. Can you please repeat that message part?
Yeah, yum is a message flag. Message is a mandatory. Message is mandatory, meaning you put some message. It's like comment. Okay, it's about first file, or else it's a Terraform changes for EC2 instance. Some message so that you can understand later with what commit is this all about. Means whenever you commit, whenever you run the commit command, it will create a commit ID. You will have the commit history. You can check the commit history with the git log. See, this is the commit ID. Every commit will have a unique commit ID, a hash code, and some commit message. Okay. And if you just want to see the brief, by the way, I told you, right? Timestamp. Monday, 4 December, 6:45. You will have the detailed log. That's one of the features of version control system. If you just want to see brief log, git log one line. First file means, okay, I can understand, okay, this is about making changes to first file. Understood? I have one file now. Shall we repeat it with another file so that the things should be clear for all of you? Shall we get
Yes, please.
Yeah.
Yes.
Also, ls will show the files in the folder. Okay. These are simple Linux commands. We will learn this separately in the Linux topic. Okay. If you are not comfortable with the CLI, you can do with GUI, like creating files and all. See, this is the file. Okay.
Hi, Preethi. Satish here.
Yeah. Hi, Satish.
Yeah, I see how to open the GUI in Windows, because I have opened, I have installed a Git and it's into the desktop. Okay. From there, if I want to work on the GUI, what's the method of, we have to open any application for that separately, or
You have installed it
command?
for Windows.
Yeah.
You have to go to the start menu and run git bash. And there you can run the commands like git commit, git add. Creating folders you can
Git
do.
bash, okay.
You can creating folders, files you can do from the GUI like you do in your daily life. Git
Okay.
commands you should execute from that git bash only, from CLI only, like git commit, git commands should be executed from CLI. Okay, so here I am creating one more file. And one more thing, please listen now. Okay, don't do it now, because if you do parallelly, you may miss the explanation. Listen now, you will also get the recording after the class. Watch the recording and do the hands-on. Okay, you will have everything of these commands, whichever I used, the installation steps in the Google Drive. Right, so please follow that and do the hands-on. Now, please listen. Okay, I'm creating another file so that it should be clear the files, the status. So I just created a file. ls will show the files. If you want, you can also check in the folder this way. So file is there. Now tell me, where is this file to? Where is this file to?
Working there.
Status, git status. Untracked means where is it?
Working directory.
Exactly, it's in the working directory. You can also confirm this way. ls will list the files in the folder and git ls files will show the files in the staging area and local. See, file 2 is not listed because it's not there in the staging area. Got it? Yeah. Now, I want to put that in the staging area. What should I do?
Git add.
Git add that file name, right? So now if you do status, where is the file now? To be committed, changes to be committed means where is this file?
In staging library.
In the staging area. Now I want to put it in the local repository git commit -m, let's say second file is the commit message. Now, if you do git status, it will be showing like 3 is clean because everything is in the local repository. If you see ls, both the files are there. Git ls files will show now both the files, right? That is the Git architecture. First, your changes will be in the working directory. From working directory, you will move them to staging area. From staging area to local repository. Clear? Everyone? Understood?
Yes.
Interesting, isn't it? Same folder, but logically, that's how it's different. Yeah? Okay. So this is what you have to understand, and it will create a commit ID. I told you, right? If you say git log, see second commit ID, the complete hash code, and the log, who made the changes. Okay, this is my system name, the person name, everything you can see. Also, if you just want to see the brief log, git log one line, simple log. Okay. And also, if you want to see what changes happen here, you don't need the complete hash ID. You just need first 7 characters. So if you want to see what changes happened there, git show. Right? It will show you what changes, what files were created. It's about file 2, right? So it will show you like the changes happened on this file. Yes, anyone, any question? If you have no questions, please unmute, sorry, please mute yourself.
Yeah, hi Preethi. Previously you were telling from GUI you can create a file. In the same way, can we create from GUI what the process you said now?
You
Or
can do that.
do it-
Git has the GUI, your drag and drop options. You can drag and drop from working directory to staging area and so on. But if you learn GUI, you will never learn the tool. Okay, so don't learn the GUI initially. Learn the CLI so that you master, you expertise the tool. Later on, you can learn, you can use the GUI on your own if you want. So
Thank you.
CLI is always preferred. And also you don't have GUI on all the OS. Always you may not be having GUI. Right? So, yeah, we have created.
Preethi, 1 minute. Can you please repeat that logs again, the previous states?
This one?
Uh,
Or
after saying log, we'll see the name and everything, right? Yeah, this one, yeah. Okay, we have changed that one and what time it has been changed. And we can restore it with that commit ID, like author.
yes, we'll talk about those. Yes, you can revert them. Yep. You can undo, you can revert. Yes. Okay. So we were talking about new files, right? Till now we created new files. Maybe it may not be always new files, right? You may have to modify the existing file, correct? Yeah. So let us see modifying the file also. Means if you modify the file, how it works. Let's modify this file. You can do it like you can go to your folder, you can open this. Okay, modify this way. Let's say hello. Okay, and I'm saving this. Okay, it was saved. Now let's say I just made some change. Now, if you see Git status, what it will tell. See again, changes not staged. Means you have to remember one thing. Git works with respect to changes. Changes means it could be creating new file, it is a change. It could be deleting a file, it is a change. It might be modifying or editing a file, it is also a change. Change could be anything, right? So Git works with respect to changes. Any change will have to go through the same process. Means, where is this modification now? Same process. Where is the modification?
Working directory.
Working directory, obviously. That's what it was saying. It is not staged. But see the difference. If it is a new file, it will be shown like untracked. It's not a new file. File is already there. Only certain changes. Means these are unstaged. There is a difference between unstaged and untracked changes. Unstaged and untracked. Untracked means new file. Okay, this is important as well. Unstaged and untracked. Untracked means if it is new file for the first time. Unstaged means already file is there, only certain changes. So what you have to do then? Again the same. You have to do, okay, let me do this way. 1 second. Unstaged. And then untracked. Untracked means for the first time. Then what you have to do? You have to do git add and then git commit. Right? Here also the same. You have to do git add and git commit. But because it's not a new file, for unstaged, you can also add and commit with a single command. -a means add and commit. This is possible if it is unstaged. But if it is untracked, you have to do separately only. Understood? But if it is unstaged, you can do this way or else this way. Clear?
Yes.
Yes.
Now let us do with a single command because it's already unstaged, not untracked. You may do separately also, but because we already have done that, let's do this. Git commit -a -m. Let's say third file or else file modified. Okay, done. Now you can see the log, all the changes. Okay, and also if you want, you see the status. It is clean, good. Means here the point to note is every change will go through the same process. Okay, same process from working directory to staging area, from staging area to local repository. One line. Okay.
Hi, Preethi. Yeah, I have one doubt here. See, you created a file and you have made the changes, and while you are executing those commands, so you are not giving any file name. How the Git will come to know to which file it is getting saved? Yeah,
See,
because I will be having multiple files, right? I will be using the multiple files here. Okay, I want to do changes on the multiple files. Yeah, one at a time. How the Git will come to know, okay, yeah, for which file I am working?
here we are not giving the file name, only in the commit message, right? Whenever you are committing, whatever in the staging area will be committed. History command will give you the list of the commands. So
it can be multiple files also.
whatever in the staging area will be committed. Okay, you are adding file 1, file 2. Later on, you can commit all of them in one go this way. You don't need to provide a file name for commit. Whenever you are running commit, whatever in the staging area will be committed. Correct?
Okay, got it.
Okay.
And if you, let's say, generally we will do this message only. We will commit whatever in the staging area will be committed. But still, let's say you want to commit only particular file. Git commit file name. Again, the same message. This way you can commit a particular file. But generally, we don't do this. Whatever in the staging area, we will commit it. That's why staging area is like a pre-check, preview. That's where you will control. Then you commit all of them. But if you want in any case this way, this is the command. Right?
Preethi, yeah, you are not giving the Git directly. You are editing file and giving Git commit -am, right?
If you want, you add before and commit this.
No, if you edited multiple files, then directly we can give like Git commit -am, right? Means it will commit all files.
Yes. Yes. That's what we did till now, right?
Yeah.
Yes. Okay, so the point to note here is any changes will go through the same process from working directory to staging area, from staging area to local repository. Okay, that's what you have to know.
Preethi Atulier, can we do select commit means if I have a do the commitment for the selected files only, can we do that?
That's what I have shown you, right? This one, git commit file name -m message.
Thanks.
See, Git is a very interesting tool. Initially, it might be like tricky or it might be confusing. Learn with a proper practice, learn with a proper understanding and do the hands-on. That will help you master the Git. Git is a very simple and easiest tool. I don't say easiest tool because like I said, it is tricky. You have to learn it properly and practice it. Then you will enjoy working with Git. Okay, so here we were going step by step in a structured way, which you are following thoroughly. Yes, are you all good?
Yes.
do the hands-on. Okay, hands-on will bring lot of change. After the session, mandatorily do the hands-on. That will help you register the things better. Okay, and help you to understand the next class. So, okay, so we have created some files and we did this. Let us do another simple scenario. Okay, an interesting scenario. I'm going to create some file. Okay, you may go to GUI and create, like I told you, I created a file here. Okay, file 3. Now, where is this file? File 3, I'm repeating the same scenario. It is in the,
Working
yes,
directory.
I want answers from all the participants. I want everyone to speak out. Yeah, it is in the working directory. Now, git add this file. Okay, done. Now, where is this file?
Staging area.
Staging area. So, I would like to git commit -m, let's say, third file. Okay, so done. Again, the same scenario, right? I just repeated it. Okay, fine. Now I would like to edit this file again. Okay, I want to modify this file. So let us do that. Let's modify this file. Okay, let me go here. I'm just writing something here. Okay, let's say I'm just writing some dummy lines. You can create any file of that sort. Okay, I just created this file. Now, is it having any stable changes, unstaged changes or not?
Yes.
It has got some unstaged changes. If to see the unstaged changes of the file, git diff file name will show you unstaged changes of the file. Do you see that? Plus indicates this is the line which is unstaged. Okay. Is this file having any staged changes? Okay, okay, let me do one thing. Let me make few more changes here. I'm adding one more line. Or else what I'll do is, this is having unstaged changes, right? I'm having unstaged changes. So what should I do? Correct?
Add and commit.
I have added. Now, is this file having any unstaged changes?
No.
No, right? So what will this command give us now? Git diff. See, no output because no unstaged changes. But this file is having staged changes. Correct? To see the staged changes, git diff staged flag will show you staged change. The same line is staged now, right? So that was shown here. Okay, good. It is having some staged changes. I will modify this again. Okay, so you have this file 3 shown as, now can you see? It was shown under unstaged as well as it, sorry, it was shown under staged. Changes to be committed means where is it?
Staged area.
The same file is also shown under unstaged area because this file now is having both staged changes and also unstaged changes, right? The second line is unstaged, first line is staged, correct? So there could be, this is an interesting scenario. There are chances that same file could be both under staged and working directory. Okay, this is the reason. Simple logic. So if the file is both in staging area and working directory, it will be shown like this. Don't get confused why the same file 3 is under staging area, same file 3 and work. This is a simple logic. Some changes were added. I run git add after some changes. And some changes were made later that. And I did not do git add. So it was shown both under staged and answer. This could be another interesting scenario, maybe from the point of interview, like is there any chance that file could be both understaged and unstaged, right? Staged or in working directory. This is the simple use case, right? Now what you have to do, you have to add and commit. So what you can do, git commit. I'll do both together, like -a yum, let's say file 3 modified. Understood the scenario, everyone? Yeah.
Yes.
Now you see status clean now. Everything is good now, right? This is another interesting scenario. Right, the same file, some changes I have added. Then I have run git add. I placed it in the staging area. And again, few more changes are there. I did not add them. So the file can have both staged and unstaged changes. Staged changes means which are there in the staging area. Simple. Unstaged means in the working directory. Untracked means for the first time it will show you like untracked. Always you have to keep this architectural diagram in your mind whenever you are doing this, whenever you are working with Git. This should be there in your mind at the back end. You relate to this diagram and you have to do. Like unstaged changes means in the working directory. Staged changes means in the staging area, right? Untracked also in the working directory. If it's a new file for the first time, it will be shown. So you have to add changes moves from working directory to staging area, from staging to local. See, remember one thing, we did not go to remote yet. Because before we go to remote, there are many things we have to learn. That's what we were doing here. Any questions? Any confusions? All good?
Yeah, all good.
Yeah, these are the Git basics. One should have complete clarity on these basics. Okay, these are very important. Okay, you can master Git once you know the fundamentals, once the basics are good. Okay, that's what we did today. We discussed about the architecture and understood the architecture thoroughly and how you modify the files. And there are many other interesting things, advanced concepts in Git, which we'll be taking up. Okay. And like whatever we have done today, if you go to our website, before that, let me take you to the here you have the quiz portal. Today's topic, whatever we have done on Git, that's a first quiz. You can complete this quiz. We'll also receive your scores. Okay, log in with the same Gmail ID you have registered with us. Okay, and take up this quiz. Okay, that is for today. And do the complete hands-on whatever we have done. Install Git, setup Git, all these were there on the Google Drive. Just give me a second. All these steps, installation things were available on the drive for you.
Hi Preethi.
Yep.
May the Google Drive link, please? I don't have it.
If you are registered with us, you will get this Google Drive. Whoever registered will have access. If you are registered still not having access, please connect with Raj. Registered means you have to complete your fee payment. Here is it.
Thanks.
Yeah, the presentation which we are doing, the hands-on commands, okay, whatever we discussed today, everything were there. Okay, and the installation on Windows, okay, installation on Mac and Linux were just single line commands. We will also do Linux installation in the coming up sessions. You can do it in your laptop today. All the things were available here. Okay, refer this when doing the hands-on. Also, the same were also available here as well. On the website also, you have that whatever commands we have discussed in the assignments. DevOps lab assignments. Okay. Today, as it initial day, you can do the same. As we go by, you can also go through these assignments. For the first day, you can go and create, install and set up everything. Am I clear? Any questions now from your end?
Where is that quiz?
Where is this?
Quiz you showed, right? You have to take that
This
quiz.
presentation?
Quiz. That
Quiz, okay, quiz on the website. Here.
DevOps.com.
Yeah, here is the quiz portal. Okay, here you have to go to get quiz 1. Sriharsha, you can install on your laptop. Whatever is your laptop, you can install Git there. You don't need to have some other operating system setup. If it is Windows laptop, you install Git there. If it is Linux, also install there. Any distribution is fine. If it is Windows also, install on your laptop. Git works on any operating system. Same commands, just installation differs. Installation steps were there in the drive. Right? All right, then that's all for today. We shall stop here. We'll get into more interesting things and the advanced things from tomorrow. Before that, watch the recording, do the hands-on, set up your lab. Lab is installation of Git for today. And you can also start taking this quiz now. We'll receive the scores. Any questions you have on that quiz also, you can get back to me. For now, if you do not have access to that drive, I'm also sharing them on the Zoom chat. Whoever don't have access, here are the links of this downloads. And the video will be posted in a couple of hours. Any more questions? All right, then we shall close here and continue tomorrow. Thank you all. You can reach out me on the WhatsApp or you can connect with Raj for any other further queries regarding the course. Thank you all. Have a good day.
Thank you. Thank you, Preethi.
Bye.
Thank you, Preethi.